Welcome back, class, to another lesson in programming in Java. In this lesson, we'll be covering data and variables. Some of the topics we'll be exploring in this lesson is going to be primitives and non-primitive data types. We'll talk about type languages, variables, constants, and casting between different types. So just a little bit of review. Remember, data is the unorganized facts that are processed, stored, or transmitted by a computer. Once that has been processed, we call it information. And data can exist in many forms, representing all sorts of types, such as instructions, text, graphics, audio, video, etc. So just like we have different types of data in computers, we have different data types in programming languages. So data in programming languages, including Java, can be categorized in two main types. We have our primitive data types and our non-primitive data types. So primitive data types are the building blocks of any programming language. They usually represent numbers, decimals, characters, text, and much more. Non-primitive data types are going to be anything that isn't primitive, is going to be considered non-primitive. And basically, non-primitive is when you combine different data types together to create more complex data structures. In the case of Java, right, we call those objects, for example. So in the case of the car, right, the car might have a few different variables, right, a few different attributes. So it might have the name of the car. So that would be represented in primitives. The year, the model year of the car, that would also be a primitive. But when you put that information together in a class and store it in an object, it's no longer primitive, it becomes non-primitive. So we'll dive into the details, right? Just giving you a little bit of a preview. I know this won't make much sense until we actually dive into those data types. So let's explore primitives versus non-primitives. So primitive data types. In computer science, primitive data types are a set of basic data types from which all other data types are constructed. So all those non-primitives that we're going to discuss throughout the class are going to be broken down into the primitive data types. Primitive meaning primal, right? Original, kind of like the original data types. So basic data types built into the language that are used to store simple values. Something to know about primitive data is that it's fixed sized, meaning that it has a predictable size in terms of the space it takes up in memory. So the storage space it takes up on your computer. So all these primitive data types we'll cover have set sizes for each type. So these are the basic building blocks for storing and manipulating data. They're considered passed by value. So passed by value means that when you use these values, they're always copied and not referenced. We'll go into more detail between passing by value and passing by reference, not only in this lesson, but in the future lessons. It's going to take more than just one lesson to kind of wrap our head around that. So Java does have eight main primitive data types that make up this programming language. So first is the int. Int, which stands for integer, is used for storing most integer values in Java. So the space it takes is 32 bits. Remember, binary digits. That's bit is short for binary digit. So 32 zeros and ones. That's all the space it takes to store an integer number. Now, we can't store infinitely large integer numbers as ints. There is a range, so it's approximately from negative 2 billion to about 2 billion, which for the most part will work for most general purpose calculations. We'll explore some other data types if you need bigger numbers. There's also the byte data type, which is used for storing smaller integer values. So this is actually a quarter the size of the int data type, only 8 bits. We call this single precision. So the range is from the numbers negative 128 all the way to the number 127. Remember, for integers, we're going to cover that later on, is whole numbers. That's what we're talking about when we say integers. So a byte is going to have a much smaller range. So you're going to want to use byte when memory efficiency is important, when you need to save space on your computing device. So for the most part, when we're writing like high-level programming, or high-level programs, I should say, in high-level programming languages, we don't really worry, you know, religiously about memory efficiency. Now, of course, we always want to write efficient code. Memory efficiency becomes super important once you get to low level programming, when you're working with more memory um, limited devices. So this could be like embedded computers or other embedded devices where the computer is basically more simple and doesn't have as much memory. Now, if we're talking about like cloud computing, for example, then you don't really have to worry about running out of capacity. But yeah, when you do have to worry about memory efficiency, Java does have your back with the byte data type. So you can use it for reading and writing binary files and other low-level programming operations. There is another integer data type called short. So this is kind of in between the int and the byte. So if you don't need the int range and the byte range isn't quite enough for your use case, you can go with the short. So this is 16 bits, twice as big as the byte and half as small as the int. So the range is intermediate, right, between those two data types. So it's negative 32,000 all the way to 32,000. So it's for small integer values that need more than a byte, but not the full range of the int type. So maybe it's like audio data, image pixel values, etc. So another option, so if you really need really, really, really big numbers, you could go with the long data type. So this primitive is used for storing large integer values. Notice it does take up more space, 64 bits, but it's a much larger range, negative 9 quintillion to 9 quintillion. So this is for bigger integers that require high precision. For example, timestamps, usually in milliseconds. Those are really long numbers. So sometimes you need a bigger data type. Now, if we're talking about fractional values or decimal values, we're going to look at the float and the double. If you want to be memory efficient, you'll go with float because it only takes 32 bits. We call this single precision. Note that this could cause rounding errors when you're doing math with float values. So precision is not important, but memory efficiency is. Go with float. Now, if you do need more precision and you want to sacrifice memory efficiency, go with the double because this is going to be double in size, double precision. So use cases are for when your decimal values need to be really precise. So maybe you're doing scientific calculations and analysis. So that data needs to be precise. You'll go with the double precision. So the range is much larger. Notice it's from 4.9 times 10 to the negative 324. So, really, really small value. And then it goes 1.8 times 10 to the 308 approximately. So yeah, it's a really, really wide range of decimal values. So the last two on our list of primitive data types is char and boolean. So char is used for storing single characters. So think of characters as anything, any keys on your keyboard, right? Any of those letters, symbols, numbers, they can all be represented as a char or character. So the size is 16 bits, which is the space it takes to represent a Unicode character. We'll talk about Unicode at the end of this lesson. So the range is from 0 to 65,000 approximately. So these are all the Unicode characters. So notice that char has like a number representation. Again, we'll talk about that once we get to Unicode. Just know char is used for storing letters, digits, symbols, and all other types of characters. So some examples are the letter A, lowercase, also uppercase, the number symbol or hashtag symbol, percent symbol, the number 5 on its own. It has to be a single character. It can't be two of them. The right-facing parentheses, the ampersand, and pretty much, again, anything on your keyboard. So Boolean, that's used for storing true or false values. If you said Boolean instead of Boolean, don't beat yourself up. I used to say that probably the first year I was learning programming. I was saying it wrong the whole time. So don't worry if you say it wrong a few times, but it is Boolean. So the size is typically 1 bit because 0 or 1, that's true or false. So range is true or false because there are no other values allowed. So the use cases is for representing conditions, logical decisions, flags, and control flow. We're going to learn about this later on where we get to make decisions with our code. And so Boolean is going to be extremely useful for that. So let's talk about syntax. So how do we actually declare or write out these values. There's certain rules depending on the data type. So for the int, byte, short, and double primitive types, there are no special syntax rules. For double, you're just writing it as a decimal. For int, byte, short, you're just writing that whole number value because these represent integers. So a literal, what do I mean by literals, right? Well, it's just another word for value. So literal is a fixed value used directly in the code representing a specific value of a certain data type. So yeah, literal, value, they can be used interchangeably. So for literals in these 4 types, you can just type out the value as is, as you usually would type it. Remember that these primitives are only used for integers, and I should qualify that by saying that the int, byte, and short primitives, so not the double primitives, are used for only integers. So yeah, this excludes the double, so I need to change that. All right, let's continue. Are used for integers. So what is an integer? Well, integer is a whole number that can be positive, negative, or 0. So it doesn't include fractional or decimal components. So double is for fractional / decimal components. So long and float, these are kind of funky in a way because you have to end these in a certain letter. So for long values, you have to end it with a letter L. It could be uppercase or lowercase. So for example, the number 100,000, you'd have to put an L at the end so that you format it in the correct long syntax. For the float syntax, which is a type of decimal like we discussed, you have to end those decimals with the letter F. If you're working with double, you wouldn't use any letters at the end. You'd just write the decimal. For the char primitive type, this one's kind of interesting. We've talked about parentheses and curly braces early on in the class, right? When we're talking about debugging and making sure that we don't do any syntax errors. Well, another syntax error that's going to come up a lot is with enclosing quotes. So for the char primitive type, you have to use single quotes around those char literals, those char values. So enclose means that it's going to have a single quote before and after the character. So some examples, right? The letter A, notice the single quote before and after. The letter Z, capital Z, single quote before and after. Ampersand, or sorry, yeah, this is the ampersand. I might have miscalled this one ampersand. Actually, I forget. This is the at symbol, so not the ampersand. My bad. So the at symbol, quote before and after, equal sign, quote before and after. So these are all chars, some more examples. But notice the syntax, right? You gotta enclose them in those single quotes. So for the Boolean primitive type, the only acceptable values are true and false. You don't use quotes for true and false. You just write the word true and false. They do have to be written in lowercase. So these are reserved keywords. Reserved keywords in Java are just words that you can't use for other functions or identifiers. So usually when we're writing code, right, we're really just writing variable names or function names or class names. You can't use reserved keywords as a variable name, function name, or class name. Now, your variable name could contain the word true, but it can't be written exactly as just true in lowercase. So maybe your variable name is I don't know, is over age or is adult true? Not the best variable name, right? But it contains the word true, so that's fine because it's not just the word true. But if you try to use the word true on its own as a variable name, that's going to be bad. The compiler will complain because these are reserved keywords. So the 8 primitive names are also reserved keywords. So you can't name a variable. We're going to discuss variables in the next few slides. You can't name them int, short, char. Those are reserved keywords. Notice there are no quotes around the true or false, so not like char. And when we get to string, notice that there's no quotes around these values, true and false. So you just write it as true and false. We'll cover that more in depth, right, once we get to the coding demo, the lab demo. But I do have some examples at the end of these slides. So non-primitive data types. These are also known as reference types because they are passed by reference. We'll talk about what that means throughout the class. So these are usually user-defined or complex data types that store references to objects rather than the data itself. So if the data is not a primitive data type, then it must be a reference type or non-primitive type. So usually reference and non-primitives are created by you, the programmer. So that's when you combine all the primitives together to create an object, a class. So then we would call that class object a non-primitive or a reference type. So in Java, the objects we design are non-primitive, but can all be broken down to primitives. So just like I mentioned early on, a car's model. So even though the car is a non-primitive, right, because it's a class object, the model of the car, we represent that as a string, right? It could be Honda or Range Rover. The year was made could be represented as an integer. So the class itself is built on the primitives, but when you put them all together and create an object, the object itself is a non-primitive. Again, we'll like we're kind of introducing these concepts, so you don't have to be an expert just yet. Once we get to like more of the class structure and coding our own Java classes, then a lot of this will make way more sense. But I think it's really important to introduce these concepts early on. So in Java, one of these the most useful types is the non-primitive string class. So we're going to be using the string class quite a lot, even though it's a non-primitive. It's a built-in class to Java. So when you download the Java SDK, it comes with the string class, a pre-built class. So the string class in Java is used to represent a sequence of characters. So not just one character, but a lot of them put together. So if char is useful for letters, symbols, digits, etc., then strings are useful for words, phrases, or longer bodies of text. So string literals are a sequence of char literals. You put a bunch of chars together, you get a string. Some built-in methods for the string class are the length, substring to lowercase and to uppercase. So these are actions that you can perform on a string object. We're not going to be using these this week in this lesson, but just again, introducing some concepts we'll be looking at later on. So for the string type, the text value must be enclosed in double quotes. So just like the char has single quotes, well, the string types have double quotes. So enclose as in it must have double quotes before and after the literal, can contain any number of characters. The only limit is the limit of your JVM memory, your Java Virtual Machine's capacity. So really it's a huge limit. Like you can go very big. So here are some examples of literals written in the string data type. So we have hello world. We have just a single letter. So you can represent A as a string if you want. That's not breaking any rules. Although if you wanted to be more memory efficient, right, you want to represent this as a char instead. An email address, that would be a common string. And then lorem ipsum, this is Latin. This is a dummy text. A lot of programmers use when they're building websites. They'll throw this dummy text in just as a placeholder. So yeah, this is another example of a string literal. So data types, we talked about the different syntax. So what does that actually look like? Notice these have names, right? They say int, double, Boolean, char, string, but they also have names after it. Age, price, is student. We're going to cover this in the next few slides in the next section when we get to variables. But yeah, just notice that the syntax on the right. Ints, you don't have to do any special quotes, nothing crazy like that. Doubles, just put the decimal in the right place where you want it to go. Just like you would write a regular decimal. You can add more decimal places if you want. And then we have Boolean. So that's the true value. Notice no quotes around it. Char is just a single character, single quotes. String, that could be a longer sequence of characters, could be an entire sentence, or it could just be a name. And notice the double quotes. And all of these, because these are all statements, end in the semicolon. So these are incorrectly typed declarations, so common mistakes. Int number, and then you use the string formatting. That's not going to work. A string cannot be assigned to an int. So Java's going to see, the compiler is going to see a string literal on the right and an int declaration on the left. Again, we're going to talk about declaration and variables in the next few slides. But yeah, this is a mismatch. Boolean, it should be true or false. So this number, this int, is a mismatch. Double, we put quotes. Even though it looks like a double, once you put quotes around it, Java's going to say, hey, this is not a decimal anymore. This is a string. So another mismatch. And then char, even though we used one single character, we didn't use single quotes. So again, Java is going to read this as a string, another mismatch. So more on primitive data types in Java, you can watch this video from Coding with John.